starting, and the other student and teacher come then because it's too early for them. I think school starts at around 7:45 or 8 o'clock. So I asked them early. So yeah,
Okay.
maybe you can start, I guess, with the guys, and as they come, it should be okay, I think.
Okay.
Right.
Thank you for having me. I'm very excited to share this information. I'm Nicole Willett, and I'm happy to be here. And I prepared this for your school. Ditta, did I say that right? Ditta, Ideal Girls High School.
Yeah, yeah, that's perfect.
Perfect. And so just a little bit, we know we live on Earth. And why do people study other planets, especially Mars? Because Mars and Earth have so many similarities. The more we learn about Mars, the more we can understand our own planet. We have only lived on Earth. And so we need to find out more about other planets so we can learn more about our planet, because every planet changes over time. And the more we know about the dynamics of other planets, the more we can understand how our planet will change and for our future, for our children. So very briefly, this is very, very brief. We have one star in our solar system, and that's the sun. We have 8 major planets, and our planet, Earth, has 1 moon, and Mars has 2 moons, and the outer planets have many, many moons. So the sun is a star. Stars make their own energy. So the biggest difference between a planet and a star isn't always size, because sometimes they can be close in size. Stars make their own energy. Planets do not make their own energy. So very briefly, the sun is at the center of our solar system. We have Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, and then another asteroid belt called the Kuiper belt, which is where Pluto lives. We have 8 major planets for our rocky surfaces that you can stand on, for our gassy, and you cannot stand on those planets. We have many dwarf planets, including Pluto, and we have 2 asteroid belts. So the size of the sun compared to the planets. So the sun is this big, and Jupiter is about 100 times smaller than the sun, and Earth is this tiny little dot down here at the bottom. So that's how much smaller the Earth is than the sun. Did you know the sun was that much bigger than the Earth? So that's something we should think about. And then this is what our solar system looks like, except it's much bigger. There's not a big enough area on the screen to show how big it is, but this is the order, and they're going in an orbit around the sun, but they're very far apart, very, very far apart. They're not that close, they're spread far. Mars at a glance. I'm going to go through this very quickly and just hit some high points for sake of time, but all the information is in the slideshow. Mars is the 4th planet from the sun, known as the red planet. It orbits the sun at about 150 million kilometers. It is regarded as the 2nd most hospitable planet for the appearance of life and for humans to go visit. The year on Mars is about twice the year on Earth, and the day is 24 hours and 37 minutes. So it's almost the same day period of daytime. And the axial tilt, which gives us our seasons, is the same within a half a degree, which is good. That means Mars has seasons, Earth has seasons. Mars has a 24-hour day, Earth has a 24-hour day. And they both have a rocky surface. So these are good things for humans to go to. It doesn't have any air though, so that is a problem. There's 2 moons on Mars, Phobos and Deimos. They're oddly shaped captured asteroids. There is water on Mars. Most of it is frozen, but there is a lot of it underground, a lot of liquid water underground. So humans need water. We need lots of water to survive. So if we go live on Mars, we're going to need to get that water from underground or melt the ice that is already there. because we need to drink water to be alive, and we need water for plants. There are lots of geographical features, lots of beautiful and interesting geographical features, including a 3,000-mile long Grand Canyon called Valles Marineris. Olympus Mons is this giant volcano here. It's the largest volcano in the solar system, and thousands of craters. Water on Mars, we know there's water on Mars. I talked about that, but most of it is frozen on the surface. We have to dig underground to find the water. Now, when we go to Mars to live, what kind of power will we have? We'll have to have solar power because there's no electricity there. We'll have to make it. So the sun is the biggest source of power on Mars. Eventually, we can put up wind turbines, and if we find geothermal vents, we can make geothermal power there as well. And we're pretty sure there's lots of areas where we can do that. We have the ability to do all these things. We just have to go do it. Internet access, we must have internet access. That's how you and I are talking. They'll need to get information from Mars to Earth and back and forth. So they'll need a way to communicate. And there is a time delay, but they have orbiting spacecraft that transmit from the surface to the spacecraft to Earth and back and forth. So that is very important so we can communicate and get information. It's very cold on Mars, very cold on Mars. It is very windy on Mars. It doesn't rain, but it does snow. There are huge polar ice caps of water ice and carbon dioxide ice on Mars. And there are dust storms that can last for months, and this can cause problems. So you need to think when you build your habitat, if there's a dust storm, how can we prevent the dust from damaging the habitat? Because we need to be able to go in and out of the habitat. The atmosphere is very thin, and the hottest it gets is about 70 degrees Fahrenheit, which is about 20 Celsius. But it gets very cold quickly. So I'm not sure how the climate is where you're at, if there's a desert area near you, but Mars is a desert, the entire planet. And so at nighttime, it gets very cold. Houses. So this is how the first people on Mars would live. So the spaceship lands and it has the piece of the spaceship. These are the spaceship pieces, and they land and they'll live there temporarily, and then they'll build a habitat. So this is the initial plan. That's where they'll live for the first couple of weeks until they build their habitat. And so you can also think about building with a 3D printer, where you take just these small little pieces of this printer, you use the dirt on Mars with some water and some cement binder, and you put it in the machine and it prints the house. And it can happen within a few hours. You can build a full habitat by printing right there. You can print a house, tools, furniture, anything you need, you can print it if you have it programmed properly. So if you landed several spaceships, you could have several of these temporary habitats initially, but later you want to build your own habitat and design it to fit for the needs of the people that are there. We know there's water, and you have a North and South Pole here. There is ice, water ice and carbon dioxide ice on the North Pole and on the South Pole. So there's plenty of water underground as well. So we can get water. Food, how would you get food if you went to live on Mars? Would you grow it? Would you bring it? How long would you stay? You have to think about, we need to eat enough food every day. So how would we get the food there? It'd probably be a combination of bringing some food and then growing some food. If you're going to stay there for a long time, eventually you're going to have to grow all your food. And then with meat, because a lot of people eat meat in the world, you'd probably have to bring dried meat initially, and eventually maybe we could bring some animals, but that might take a little while. Travel, you would have to know how to travel on Mars. So you'd have to have little rovers and vehicles, cars to run on Mars. And they can't be gas powered because there's no oxygen in the atmosphere. And we're not going to take gas fuel to Mars. They would be solar powered. So the top 10 things we need when we live on Mars: food, water, houses, vehicles, energy, entertainment, communication, work to do to keep our minds and bodies busy, comforts of life, and most importantly, each other. The most important thing we need are each other. We need to have communities and relationships with people to stay psychologically healthy. And then here are some habitats. So you ask for pictures. You asked for photos of some of the habitats. I just did an international cohort in Los Angeles a couple of months ago. This is an example of a habitat that one of the groups, this was the winning group actually right here. It was all girls, by the way. The number one group was made of all girls. And they built their habitat, but you see this little plastic stuff over the top. They covered it with tarps. So when the wind and dust would fall on the habitat, you could clear off the wind and dust so it wouldn't affect the mechanics of the habitat, because the doors are going to have to open and that dust will get stuck in there. Here's another one on the bottom here. This is just another example of a habitat these students made. This did not win. And then here, I like this one over here on the bottom because they made different parts that had little connectors where you could travel from one area to the next. And then this one was more of like a funnel shaped because they wanted to bring in sunlight and heat it using the sunlight. So these are some of those examples. Do you want me to look at the instructions? You want me to show the instructions? Can you see them?
You guys want to go over the instructions that we have it for the habitat?
जी सर इंस्ट्रक्शंस चेक की थी स्टाफ ने
Right?
जी
Yes.
सर
Okay.
सर और एक
You guys want us to go over it?
It's very simple. You need poster board or paper or cardboard. Any type of paper or cardboard, you don't have to buy new. You can use recycled or upcycled cardboard or paper. As you saw in the pictures, they just use paper and tape. That's all they use. They didn't
Right.
use any fancy materials.
Mhm.
Tape, scissors, something to cut with, a ruler, measuring tape, pencils, protractors if you want precise angles, and then markers or paint or crayons for decoration. And then they have to design it, they have to plan it, what shape do we want, how many buildings do we want, what is needed to protect the astronauts to keep them alive. So they have to think about all these needs of the community that you're building on Mars. And then they design it and create it. And so we plan, we measure, we cut, we paste, we assemble. And so basically the students, there's different options: dome roof, flat roof, doors or windows, reinforcing, decorating, and final check. So there's different options for the students and the teachers. They don't have to all do the same. It's better if everybody does a different habitat. And you probably need, how many students are in each class?
I think we have we have 8 or 6 from the classes.
सर almost 25 to
No.
20
In the team, right? You have 2 teams, right?
in the team में कितने सर 8 सर 8 सर
4, 8. We have 2 teams, 4 students in each team, right?
Okay, so just split them up into maybe 3 to 4 people a team if the numbers work out. Because you don't really need 4 or 5 people in a team. That's too many.
Okay. So they can, what you are suggesting is everybody can make their own, right? Whatever.
You could do every single person do their own if you have the resources for that, but I wouldn't have more than 3 people on a team.
I see.
Yeah,
Oh,
there's not enough work to do.
I see. For the small habitat project, right? So this is the first
Right.
time they are going over it. So hopefully, I think, yeah. So
Yeah.
maybe, Ms. Azra, you can take a note that make one more, and then you will have total 9, and then you will have 3 teams, right? We have 3 teachers.
okay, sir.
3 teams,
Okay,
yeah.
sir.
All right.
Yeah.
Sir, there should be 9 people, sir, total.
No, 3 teams you can make. You can have 8, 3, 3, and 2, or you can add
Yeah.
one more, and then you
Or
can have
2,
3
2,
teams.
2, and 2. You could do
Yeah,
2,
you
2.
can have 2, 2, 2,
Yeah.
right? 4 teams.
Okay,
Yeah.
sir. One
Yeah.
more.
Now, if they were making the big habitat, so this
Yeah.
is for the small habitat, if they were
This
making
is,
the big
yeah,
habitat, you would need more people.
yeah,
But the
yeah.
small habitat, I think, how much time are you giving the students?
Mm,
How much time every day you guys spend with the students for this project? Is it
one
after school?
lecture, sir. One
Sorry?
lecture, sir. One
One
lecture,
lecture,
35
45
minutes.
minutes, right? So it is 45 minutes every day. Every day, or is it every other day?
Another day, sir.
Every other day, right?
Mm.
So 3 days in a week, 45 minutes each. They're given.
Okay, so how many weeks? Is it for 1 week, for 2 weeks?
They, I guess, started from last week, right?
Okay,
Earlier. So yeah, that is another thing we were wondering how much time they should basically spend, right?
so for the building part, if you have 45 minutes between the design and the cutting and pasting and building, I would say no more than 3 lectures. That's probably plenty of time.
So in 1 week they should be done, right? Like the one
Yes.
day. Okay.
Yeah, once they learn all the background information. But yeah,
Mm.
definitely within a week for sure.
Mhm.
Yeah.
I see.
3 class periods for the building, I would say.
Mhm.
I recommend. Now, there's
Mhm.
always circumstances you can't control.
Okay.
And there's the instructions for teachers here. So this just gives teachers the basic approach. Feel free to interpret this into another language if you need to. Understanding Mars, engineering and design, problem solving, teamwork and collaboration and creativity. And then it just goes through the materials and the procedure. It's very simple. And it's not scary. It should be pretty easy for the students. The things they'll come up with are pretty amazing. So I think you'll be surprised at how creative they'll get.
Yeah, so one thing I guess here for the teachers is like you guys can guide them, but after giving them all the initial information, let them think about it, and then let them design, right? So you guys
Exactly.
can, if they make any mistake or anything, you guys can correct them and guide them toward the correct path, but let them do it, right?
Yes.
Give them the resources, the cardboard, the scissors, the tape or whatever, and then uh, the design, whatever they think. So let them make it, right?
Yes. You don't have to give them more than the basic instructions. Design
Right.
it and make it, because they're so creative. Some of the things they're going to come up with are just going to be so amazing.
Yeah.
And so I look forward if you could take pictures and send them to me, and we'll put them on our website, if that's okay. If you
Yeah,
don't,
sure.
if you don't want the students in the pictures, they don't have to be,
Mhm.
because I understand for privacy reasons, but if you could take pictures of at least the designs for sure, and we'll put them on our website.
Yeah. So
And
yeah, while they are making it or once they are done, so you guys can take the picture, make a short clip, and then we can share it here, right? We can,
right,
and then they can, the Nicole can put it on the Mars website, right? Mars
right. Our
website.
PR director will
Yeah.
do that. Yeah.
Yeah.
And so the other projects I think are very interesting too. Like you can make a Mars rover. There's many other projects in the folder. If you want to do other projects, I'd be happy to help you with that as well. There are student lectures if you want them to research a certain subject and then tell a story about it and make a slideshow. There are many other options in the folder, and there's a lot in there. And let me look at it real quick. And if you don't mind, I'll pull that up.
Sure, no.
And it'll just take me a second. Come on.
So maybe, Nicole, what I'm thinking is maybe we can give them 1 or 2 weeks, and after that they can send the pictures, obviously.
Yeah.
But we can also have a review what they did it after maybe a couple of weeks, right? And then we can
Right.
think about other projects also. Yeah.
And then here's a good document. I believe you have this whole folder.
Yeah, I have the whole folder.
Okay.
I have the whole folder. Right?
This is a beautiful document that I made over the last 20 years teaching Mars about how I go through the school year teaching Mars. And there's little bits of information here for the teacher, just the order I go through and the spacecraft. And I have slideshows. If you guys want me to share slideshows, I can do that. And then I wrap up the section with a student lecture, and then we do a big project. And so this goes through all of that. And it's and then we have, if you make a Mars rover, you can make an obstacle course for the rover. You're going to build a habitat. You're going to, what else do I have? There's 2 rover options. One is where you buy a big Lego rover, and one's where you build it out of recycled materials. There's a Terraforming Mars project. It's a little more extensive. The student lectures and Humans to Mars. So all these are different projects.
Right.
If you're interested in any of those, just let me.
No, sure. I think for sure. I think first we just go through this exercise and let's see how it goes, and then we can. I think the student, they will also develop some appetite, and then we can look into the
Okay.
other ones also, right?
Yeah, it sounds great. I'm excited.
Yeah.
Does anybody have any questions?
So yeah, students or staff, you guys have Miss Ikra or Omna, if you guys have any questions.
Assalamualaikum.
Walaikum.
I'm Rina Shane. My question is that why we are spending so much money to make the Mars habitable?
Well, there's a long answer to that, but I'll give you the short answer. The short answer is our star, the sun, will not survive forever, and we need to learn how to live on Mars as a bridge to the stars. So if we don't learn to live on a planet close to us, we're not going to be able to go to another solar system when our sun starts to die, because the sun isn't going to live forever. And if humans are still here, if we're still here, by the time the sun starts to die, we need to be able to go somewhere else. And living on Mars is a starting point to learn how to go out far, far away, because the nearest habitable planet is 4.2 light years away, which is trillions and trillions and trillions of kilometers. I'm just going to go practice there first. So it's better to practice close by and learn how to do it before we go to another solar system.
Yeah, so another way to put it, look at it is also, we can look at the fate of the dinosaurs, right?
Yeah.
So if
Yes,
you are sitting
absolutely.
here, something happens to Earth, the humanity is gone, right?
And that will happen. We do not know where all of the asteroids are. We do
Right.
not know where all of the meteors are.
If you go on live somewhere else, so at least if Earth is gone, so some people will survive on Mars or anywhere else, right?
Right.
That's kind of insurance policy for people.
It means without sun, we can live on Mars.
Sorry?
Without sun, if there is no sun, that life is possible on Mars.
No.
No. But if you know how to go to one planet and then then you know how to go to the second planet or to a second star, right? So
Right,
you can move
yes.
to the next star, right? There are
Yes.
millions and millions of stars out there, right?
Yes.
Till
Billions,
when it,
hundreds of, yeah. Mhm.
till when it would be possible to live on Mars?
Sorry?
And when,
Till when it would be possible to live on Mars?
we could go there now.
Yeah, we can go.
We just have to take everything with us. Yeah. We just have to have oxygen in, we have to create oxygen. They're doing that now with something called MOXIE on Mars, MOXIE. They have a machine that's making oxygen out of the carbon dioxide in the air. We need to have a machine like that inside a habitat that is creating oxygen for the people so they can breathe. So that's one thing. There's a lot of
A
things.
little guess, how many years?
Sorry?
The SpaceX is saying that they're gonna try to send people within the next 3 or 4 years.
Around 2030, they have a plan to
Yeah.
land people on Mars, right?
Right.
Around 2030.
Thank you so much.
You're welcome. Great
Mm.
questions.
Yeah.
Thank you, ma'am.
So any student there, you guys have any question? Tara, you wanted to ask something?
कोई सवाल पूछ
that they can't understand.
They can't understand English. sir.
Sorry?
All lecture is in English. Said students are saying all the lecture is in English, so they are not understanding what is being told.
Oh, I see. But they can ask the question about Mars and you guys can translate, right? They can ask in Urdu, right? Yeah. Yeah, if any student has a question, they can ask in Urdu. We are here, we can translate, right?
I had a question about the atmosphere.
Mhm.
You were saying, well, it is unsustainable right now, but would there be any way to like restore the atmosphere to what scientists hypothesize it once was, or how Earth has its atmosphere? Like, is there a way to melt the ice caps or something of
Yeah.
that sort?
So that's a great question. So one of the projects is called Terraforming Mars, and that's where the students research how to change Mars in year 0 to year 1000 from how it looks now to a Mars, to an Earth-like planet. So the Mars flag in my slideshow, the Mars flag, the whole reason for these colors is red Mars for how it looks now because the clay is red, green Mars where you plant plants, and blue Mars to where the atmosphere turns blue like Earth's. So that's the point of the Mars flag. You need to plant lots of algae, grasses, lichens, all of those types of things to start photosynthesizing and producing oxygen. Warm up the planet, melt the polar ice caps, have running water, and change the atmosphere to have more oxygen in it. Yes, absolutely.
you.
Yeah, you're welcome.
Yeah. So, yeah, I see somebody want to ask the question. Yes. Go ahead, please.
Assalamualaikum.
Walaikum salam.
Hi.
मैं हुस्ना हूँ.
Okay. So her name is Hasna. Okay.
From class 7th.
From class 7. She's from class 7 and her name is Hasna.
Hello, it's nice to meet you.
Thank you.
Yeah, you can ask in Urdu. Right?
जमीन के इर्द गिर्द जो ओजोन लेयर है, क्या मार्स के इर्द गिर्द ओजोन लेयर होगा?
Okay. Yeah, so she's asking, like we have ozone layer around Earth. So do we have ozone layer around Mars?
No, we will have to create all of those things. Yes, correct. No ozone. Great question.
So Mars does not have any ozone and Mars does not have any magnetic field either, right?
Correct. Right. It has a little bit in little spots. It has little tiny spots, but it's not a global magnetic field.
Right. Yeah, it does not have any ozone. So any other question?
When we're looking to have a habitat, one of the areas, are we looking for more the cooler regions or more of the warmer regions?
That is for you to decide.
Oh,
That's
Where you
part
want
of
to
the
go.
project. That's part of the thinking. What's best? What, you have to think about the geology, like what does the land look like? What is the temperature? So you have to take all these things into consideration when you build your habitat. So it makes sense. So the assessment, so when it's being graded, did the students think about it? Because there's no real right or wrong answer.
Yeah.
It doesn't make sense. Does it make sense? Is the thinking sensible? Yeah.
And
I
then-
guess we have one more question.
जी सर अक्सा
आप उर्दू में पूछिए ना, अगर
अच्छा।
हौसला ये नहीं है तो लोग कैसे जिंदा रहेंगे?
आप उर्दू में पूछिए people survive without या उर्दू में
Assalamu alaikum.
Walaikum salam, beta.
I'm from class 7. My name is Iksa.
Hi.
Her name is Aksa and she is also from class 7.
Okay.
How will people survive there without ozone layer?
She is
Without
asking the same
oxygen or
question.
ozone?
Yeah, without the ozone layer, right? Or without the oxygen? Your question is, आपका question oxygen है या ozone है?
Ozone layer.
Ozone she's asking about.
You just have to have some type of protection to cover your body so you don't get cancer.
Yeah.
The ozone layer here prevents us from getting cancer, but not 100%. So you'd have to be covered so you wouldn't get exposure to the radiation.
But beta, ये आप लोगों का problem है. You guys have to solve it.
Right.
That is your problem, right?
Right.
You know that it does not have ozone, so you need to think about it, what to do to solve that issue, right?
Right. I think Sarah had another question.
Sarah, you have another question?
You're muted.
yeah, sorry. My
That's okay.
question was, there's like a lot of like stuff talking about like Mars and colonizing that, but what about like Io and Europa? Because both of those are like predominantly like water, or like there's more water or like
Well,
more habitable that way.
Europa there's a space mission going to Europa like this month or next month, like really soon. It's really not habitable because the ice is unstable. And Io is a volcano planet. You might be moon. You might be thinking of Enceladus, which is very much like Europa. Same problem. There's too much radiation from the big planets next to it, and there's no protection. And the ice is unstable. It cracks apart. It seals together. So if you built something there, you might fall into the crack.
Yeah.
So, but great. I did my culminating research on Europa when I got my bachelor's degree.
Oh, nice.
Yeah. And that was years ago when none of my professors knew what it was. Yeah, that was many years ago.
So,
Great questions.
yeah. So,
We have a minute.
any
आ जाइए बेटा next question आ जाइए
Hey, we're running out of time,
we are
so
running out of time. Yeah, we only have 1:36. So if you guys have more questions, we can re-log in. But yeah. Well,
ओके सर ओके सर आप हम दोबारा से लॉग
okay, so they want to re-log in, right? So is it okay, Nicole? Okay.
just a few minutes. It's almost midnight here.
Oh, okay. So yeah.
I'm tired.
So,
I'll come
okay,
back.
so it's already midnight. Nicole is
It's
saying, so
11.
maybe a few
It's
more
11
minutes.
oh nine. Yeah,
Okay.
but come back.
Okay.
Come back on the same link.
Okay. Thank you.